Okay, the second question for static modeling is about a surface model that we need to determine the maximum stress and displacement produced by this load. You'll see that we have a aluminum 6061 T6 plate, which is a surface model, and then the plate thickness is given as a quarter of inch, 250-pound force applied to this edge, while the other edge is a fixed geometry and has been fixed. So we need to first create that surface model that is given based on that dimension. So start a new part. Since all the dimensions it says in inches, you need to change it to IPS. Similarly, I would select, okay, I'll go to the front plane and I need to create my a sketch and then convert it to surface and create a static simulation for that. So the part that I have is pretty much start from origin, coming all the way to here, go to here, come here. I guess I have to create a sort of like a half circle here, going here, all the way to this point that is perpendicular here. And maybe at this point I will create a center line to be able to mirror what I draw with respect to this line. Select all of my entities, mirror entities about this line, center line, hit OK. Now I have to define my dimensions. So overall length is given as 8 inches. So here to here is going to be 8. There's 5-inch total height of it, so that's a 5-inch. Radius of this half circle is 1 inches, and the distance of this center with respect to end is 4 inches. That makes my sketch fully defined. Exit out of it. Now I have to convert this to the surface. So I go to surface mode and we'll create a field surface, for example, by using this sketch, then hit OK. You might use planar surface as well. They both have both the same result. Okay, now going to simulation, create a new study. Call this a surface simulation, and it's a static model. First, I need to create a thickness for this part. Right click, go to definition, and it would be thin, a quarter of inch. So a quarter of inch thickness that we have. Okay. It doesn't show the thickness on your model. It does take into account that you add thickness to that, so don't worry about that part. You need to define a material for that. So right click, apply material. It would be aluminum 6061 T1. So aluminum alloy. Look for 6061 alloy. So that's the one we have. Okay. And then we need to apply a fixed geometry, which the fixed geometry would be this edge. Okay. And then apply a load, which now would select force here, and I will select this edge entirely. But we need to select a direction. You will see that it's not in the direction that I wanted. So instead of going normal to that, we'll select a direction, and I need to create a plane to define that direction. So maybe you can select any plane that I have. I can go with front plane, should be fine, and change it to English along fixed direction. I have to have 250. Direction is accurate. 150 applies here. Okay, I have my fixed geometry forces. I can go and create my mesh. I can stick to the default. So hit OK. This is the mesh that we have, and we can run the simulation. So you'll see that if I right click and animate, the plate is gonna be stretched in the direction of the forces that it's applying, which is what expected. There's no bending or anything. So I have to create a few things. First, a stress plot in PSI with max and min stress points. Right click, go to definition. So we need to change it from the unit from Newton per meter square to PSI. Go to chart option. I will show maximum and minimum points. Change it to floating for better readability. And halfway of this circle is the maximum pressure of 563, a minimum of 2.669 as a load stress. They wanted the problem on displacement plot in inches. So if I go displacement plot, it would be, I have to change it from millimeter to inches, and then show maximum and minimum. Of course, minimum is 0 associated with the fixed geometry. Okay, so 0 displacement here and max displacement with all over here. Maybe I have to add in a floating, have to add a little more digits of that instead of 3. Yeah, that would be about right. So very small displacement that you can calculate. How about factor of safety and minimum factor of safety? So right click on result and go to factor of safety plot and create factor of safety, which shows the minimum factor of safety is 14 for this problem. I hope it helps to understand a surface modeling versus static simulation. Thank you.